All right, mathematicians, we are back with section 2 of chapter 3, solving linear equations by graphing. So previously you graphed linear equations by using tables and finding roots, zeros, and intercepts. Now we're going to solve linear equations by graphing. And then in the second video of this section, we're going to estimate solutions to a linear equation by graphing. So here's the new vocabulary that we're going to talk about. Linear function, parent function, family of graphs, root, and zero. So first in this video, we're going to talk about how to solve an equation by graphing. A linear function is a function for which the graph is a line. The simplest linear function is f of x equals x and is called the parent function of the family of linear functions. A family of graphs is a group of graphs with one or more similar characteristics. And again, when you see linear, think line. The graph is going to be a straight line. It's not going to have any curves or bends or kinks in it. It may be horizontal, maybe vertical. Most likely it's going to be diagonal, but it could be increasing or decreasing. Any of those things as long as it's a line. Okay, so the parent function f of x equals x is the same thing as y equals x. And what that means, basically, it's the simplest linear function because it just says that y equals x. And if you go to any point on this graph and you look at the coordinate, pick a point on the graph and look at the coordinates, the y and x values are going to be the same because the y value equals the x value, right? So for example, this point I highlighted is over 2, up to, it's 2, 2. Any other point that you pick is going to have the same x and y value. The type of graph, obviously it's a line. The domain means the set of all x values for the function is all real numbers because you can pick any number in the x for an x value and it would work. And the range is also all real numbers, again, because you can make the y value anything you want by picking the appropriate x value. All right, so the solution or root of an equation is a value that makes the equation true. A linear equation has at most one root. You can find the root of an equation by graphing its related function. To write the related function for an equation, replace the zero with f of x. So we'll talk more about that. So a linear function might be 2x minus 8 equals 0. Or excuse me, a linear equation. It's where you have 0 on the right side and your x and constant on the other side. Okay, so if you replace the 0 with f of x, you get the related function. Now, to be a linear equation in this sense, you have to have it set equal to 0. All right? So the graph of y equals 2x minus 8 is right here. And notice the equation that the number that makes this true is the root. So if you plugged in 4, so 4 times 2 is 8 minus 8 be 0. And on the graph, that corresponds to this point right here. So the value of x for which f of x equals 0 are called zeros of the function. The 0 of a function is located at the x-intercept. That's what I was just showing you of the function. The root of an equation is the value of the x-intercept. So I know I just said like root, 0, x-intercept, and solution. Okay, so 4 is the x-intercept of 2x minus 8. 4 is the solution of the equation 2x minus 8 equals 0. 4 is the root of the equation 2x minus 8 equals 0. And 4 is the 0 of the related function f of x equals 2x minus 8. So all 4 of those things are really talking about the same characteristic. They're all talking about, well, we can use them interchangeably. The x-intercept of a linear function is the same thing as the root, and the root is the same thing as the 0, and the 0 is the same thing as the solution when the equation is set equal to 0. So all 4 of these are basically 4 different ways to talk about the same thing. Okay, so let's do an example. Let's solve this equation, 0 equals 1/3 x minus 2. We could solve it algebraically by just solving for x. So add 2 to both sides, multiply both sides by 3, or you could do 3 over 1 if you like to multiply by the reciprocal of the fraction, but multiplying by 3 will be fine, and you get x equals 6. So x equals 6 is the solution to this equation, it would be the x-intercept of the related function f of x equals x minus 2. It's the 0 of that equation, and it's also the root of that equation. If you graph the function, it would look, no, it would not look like that. Undo. The equation would look like this, and your x-intercept would be right here at 6. Okay? All right, so the other way to solve it is to solve by graphing. So here is a different equation, and if we're going to solve a linear equation by graphing, we first want to write it such that 0 is on the right side of the equation. So you got to get rid of that -2, add it to both sides. It is a like term with the constant 1, so we put those together to make 3. All right, don't add it with the 3x and make it 5x plus 1. Bad idea, okay, because they're not like terms. So the related function, you replace 0 with f of x, so f of x equals 3x plus 3. And to graph the function, we just make a table, pick a couple values. If we pick -2, you substitute it in, you get -6 plus 3, which is -3. And if you pick -1, you get 0, so -1, 0. Now, here is a graph. So we plot the 2 points, -2, -3 is right about there. And 0, -1 is right about there. And if we graph those, pretend that's a straight line. All right. So the graph intersects the x-axis at -1 right here. And so the solution is -1. All right, now that might look like more work than solving it algebraically. And I gotta admit, it is. But when we graph it, we're practicing how to graph because graphing is going to come up for the rest of your life in all of your math courses. So it's good to know how to graph. And also, one of the goals we want is for you to be able to see what's going on algebraically, like when you're solving the equation and figuring out things, but also know how that information translates on a graph. So that's one of the reasons we bounce back and forth and show you different methods. Even though one method may be simpler or less work than the other, we want to be able to bounce back and forth so that we can easily translate, okay, this is what it comes up whenever I solve it algebraically, this is how it looks, and then this is how it looks in a table, then this is how it looks on a graph, and then if it's in a context of a problem situation, that's how I would interpret it, okay? So here's 2 for you to try. Go ahead and pause the video and hit play when you're ready. Oh, by the way, you can pick. What I'm going to do is I'm going to solve this one by graphing and this one algebraically. Okay, so you can do them both ways, both either opposite ways of what I do, whatever. Go ahead and hit pause and hit play when you're ready. Okay, we're back. So the first one, we want to graph the related function f of x equals 2/5 x plus 6. So if I make a table of values, I'm going to pick values that are easy to multiply by 2/5, so multiples of 5. One of the easiest is 0, right? So if I substitute 0 in, 0 times 2/5 is 0, and y would be 6, all right? Now, the next number, I would not put 1 in because then you'd have 2/5 times 1, which is 2/5 plus 6. Then you have to worry about adding fractions, which might be easy, but it's going to take extra time. So let's pick multiples of 5. How about 5? Okay, so if I substitute 5 in, 2/5 times 5 is going to be 2, plus 6 gives you 8. Now once you have 2 points, you can graph the line. If you want to get a third one, I'd pick 10. 2/5 times 10 is going to be 4, plus 6 gives you 10. Then you can plot your points on the graph. So 0, 6 is right here. 5, 8 is right there, and then 10 is right there. Now you can see if you graph the line, you're not really going to hit, it's going to go down here and be back here somewhere. So what we might want to do is plot a couple more points, maybe do -10, if If I plug in negative 10, that would make this negative 4 plus 6 would give me 2. So negative 10 would be 2 right here. All right. And then if you continue going on, you'll see that the graph eventually crosses the x-axis back here at negative 15. Okay, but just make sure if you're solving it by graphing, make sure that you graph enough points so that you can get close enough to where the graph crosses the x-axis. And unfortunately, this one fell off, or didn't fall off, wasn't on the graph that I put on there. But we can always extend it, no big deal. All right, so the solution to that equation is x equals negative 15. That's also the x-intercept of the graph. It's the root of the equation. It's also known as the zero of the equation. All right, how about 1b? So negative 1.25x plus 3 equals 0. Solving it algebraically, two-step equation. Subtract 3. You get negative 1.25 equals x equals 3. Then divide both sides by negative 1.25. Those cancel, and you would get x equals, oh, forgot the negative here. I was wondering, I knew my answer was going to come out positive. So when you subtract 3, you should get a negative here. So negative divided by negative is a positive 2.4. And as a fraction, that would be 12 fifths. And as a mixed number, it would be 2 and 2 fifths. Okay. Now, when you're doing your assignment, make sure you enter your answer the way that it specifies if it does. Okay? Alrighty. So for equations with the same variable on each side of the equation, use the addition or subtraction to get, use addition or subtraction to get the terms with variables on one side, then solve. So for example, if we have an equation such that 3x plus 7 equals 3x plus 1, we want to, we could solve it algebraically. So we'd subtract 1 from both sides and get 3x plus 6 equals 3x. Then subtract the 3x from both sides and get 6 equals 0. Okay, now here's a funny situation. You probably saw this coming when you had 3 x's on both sides. But when you subtract 3x from both sides, all the x's cancel. And I have a statement that's false. I have a statement that's false. 6 does not equal 0. What does that mean? That means there is no solution to the equation. Okay, and if you think about it, if you plug a number in, you're going to multiply it by 3 and then add 7 on this side, but on this side you're going to add 1. It's never going to work out because you're adding different amounts to either side, so never going to work out. Now, I will say that the related function, since this is set equal to 0 here, the related function, remember you replace 0 with f of x equals 6, the related function, is going to be a horizontal line going through 6 on the y-axis. It would look like this. It would be a horizontal line like that. And if you think about it, a horizontal line's never, it doesn't have any diagonalness to it or a slant to it. So it's never going to like come down to touch the x-axis anywhere. So it never has an x-intercept. So that's why there's no solution for that one. All right, how about we solve this one by graphing? Again, we want to set the equation equal to 0, so we're going to add 6 to both sides. Then subtract 2x from both sides. You get 2 equals 0. Same thing as before. We already know it's going to be no solution, but if we graph it, it's going to be a horizontal line going through 2 on the y-axis. Since it's a horizontal line, it doesn't have any steepness to it. So it's not diagonal at all. So it's never going to eventually touch the x-axis and cross it. So therefore, there's no x-intercept. So there's no root. There's no 0. There's no solution. There's no x-intercept. Those are the 4 different ways to talk about this. So at the end of the day, there's no solution. Alrighty, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, so we're back. This one, 2a, we want to add 5 to both sides. You get 4x plus 8 equals 4x. Oops. So subtract. Let's just clean this all up a little bit. So subtract 4x from both sides, and you get 8 equals 0, which is false. 0 does not equal 8. If you graphed the related function, it would be f of x equals 8, which is a horizontal line going through 8 on the x-axis. And that means there's no solution because it's a horizontal line. Also, when we solve the equation down, we got 8 equals 0. That's a false statement. There's no solution. So there's no solution, there's no root, there's no 0, there's no x-intercept for this one. All right, the second one. Let's subtract 2 from both sides. So you get negative 3x equals 4 minus 3x. You can see the same thing's going to happen here. You get 0 equals 4, which is a false statement, so there's no solution. If you graph the related function, be a horizontal line going through 4 on the y-axis, there's no solution, there's no root, there's no 0, there's no x-intercept. Okay, same thing as before. All right, well, that's it for this video. Stay tuned for the next one, and we're going to estimate a solution by graphing. All right, guys, we'll see you there.